Okay, so we're going to start with question 1. So looking at question 1, we can see from the question itself that the focus is going to be on factorising. So we have to have in our head those different types of factorising that we've gone through in class. So your sum of two cubes, difference of two cubes, your difference of two squares, quadratics, grouping, highest common factor. And we kind of go through them in that order to tell us where we're going to start, because they give us a good plan, I suppose, for how we're going to tackle the question. So looking at this first question, we're trying to identify which of these types of factorising it's going to be. And the giveaway here should be these x squareds, y squareds, all square terms. And then we look at the numbers 144, 100. These are square numbers. We're seeing a lot of square terms, square numbers. So that should tell us that we're going to be looking at a difference of two squares. And the key thing to start a difference of two squares is that we take each of the terms and we rewrite them as something squared, and then we can move to our brackets. So to start with that first, 100x squared y squared can be written as 10xy all squared, and the 144y squared can be written as 12y all squared. Once we have that done, we can move to our brackets. So our 10xy minus 12y, 10xy plus 12y. Okay, and that is your answer then for 5 marks. An alternative way that a few people did that we also gave your 5 marks for was to start by taking out a highest common factor. The highest common factor, the biggest thing that will divide into both 100x squared y squared and 144y squared, is 4y squared. That leaves us with 25x squared minus 36. Once we have that done, we should recognise that that middle bit in the brackets, this yellow part here, is also a difference of two squares. So I can rewrite that as 5x all squared minus 6 all squared. And then same as we did on the left hand side, I can move to my brackets then, 5x minus 6, 5x plus 6. So those were our two answers that both got 5 marks, both of them acceptable. Okay, whether you went straight for the difference of two squares or whether you took out your highest common factor first. Looking at the next question, we should take a second again just to really identify what type of question are we looking at. So what are the telltale signs for us here? Well, we can see that we have some cubed terms. So we might be thinking maybe it's going to be a sum of two cubes, not a difference of two cubes, because we can see there's a plus, so it's going to be a sum of two cubes if it is that. What is throwing us off is looking at the numbers. We have 6 and we have 48. Neither of those numbers are cubed numbers. So we're not going to be able to start straight into our sum of two cubes. We can move our way down our list of factorising, and the place we're going to have to start is taking out a highest common factor. So we're looking for something that divides into 6x cubed and 48y cubed, and that's going to be a 6. So we have x cubed plus 8y cubed. Once we've got this far, we should again recognise that the part in the brackets here, this expression in the brackets, is actually a sum of two cubes. Because we have an x cubed, we have y cubed, but this 8 is also a cubed number. So we can take a second then to rewrite our term in the bracket. So we have x all cubed plus, and this becomes 2y all cubed. Then we should remember our formula for our sum of two cubes, and what we end up with is x plus 2y, x squared minus 2xy plus 4y squared. And that was our answer then for our 5 marks for that question. Okay, key things there are recognising the sum of two cubes, recognising that we had to start by taking out a common factor first so that we were able to do a sum of two cubes, because until that 6 was taken out, the question wasn't a sum of two cubes. Once we've taken that out, it's remembering our formula, remembering where the minus goes, where the plus goes, all of these things. Okay, looking at part C then, we had to express t as the subject of the formula. Okay, so let's just make sure we understand what we're being asked to do. We are being asked to rearrange this formula so that we get t is equal to something. And the only place that we should have t is on this left hand side, just one t. So t is equal to something. So we're going to start off by kind of undoing, I suppose, everything that's happening to the t's on the right hand side here. So let's start by squaring both sides. So we're going to get e squared is equal to t minus k over k by 1 plus kt. Okay, the reason we're squaring both sides is to get rid of that square root. So it eliminates the square root on the right hand side, and then on the left hand side we end up with the e squared. Okay, what I'm going to do at this point is actually just multiply out that bottom line as well. You could not do this and that would also be fine, but just to keep it nice and tidy for myself, I'm going to multiply that out. What I'm going to do next is I'm going to multiply across by the bottom of that fraction. So what that means is that here I'm going to have k plus k squared t multiplied by e squared, and on the right hand side I'm just going to be left with t minus k. So I've multiplied across by multiplying both sides, if you like, by k plus t, and the same on this side. Multiplying both sides by this term, k plus k squared t. Okay, now that I have that done, I'm going to multiply out this bracket. So I'm going to be left with e squared k plus k squared t e squared is equal to t minus k. Okay, at this moment we might want to just take stock a little bit and remember where we're heading. So we want to get t is equal to something. The minute we have a t on this side, we also have a t here. I said at the start I just want to have one t term and have everything else on the other side of my equal sign. So in order to get there, I'm going to need to bring everything over to the same side. Everything that has a t, I'm going to bring to one side. Everything without a t, I will bring to the other side. Okay, so let's do that first. So over to this side, I'm going to have k e squared k, and on this side t minus k squared e squared t. Okay, just rearranging that a little bit, but not actually changing the meaning of it. So now that we've got this far, we're going to factor out the t on the right hand side here. So keeping the left hand side the same for now, I'm going to take out a factor of t. That's going to leave me with 1 minus k squared e squared. And finally, I'm just going to divide by that bracket, the 1 minus k squared e squared, or e squared k squared, whichever order you have those in. Okay, and that is your answer then. So we can see that we've ended up with a term where we have t on its own on the left hand side and then everything else on the right hand side, similar to how we started with e. So the question really is asking us to rearrange this formula so that it looks something similar but with t is equal to instead of the e is equal to that we started with. Okay, the key thing here might be that middle step. Okay, this part here. So getting all the t's on one side and then factoring them out. That was something that maybe people were having an issue with. Finally, for question 1, let's look at this question with perfect squares. Okay, we should remember that a perfect square is a quadratic that can be written as kind of a plus b all squared. And when we multiply out those brackets, we get this quadratic. So it's one that can be reduced to an expression squared. So to look at this question here, we can see that generally, and we should remember as well from doing our perfect squares before, that your a squared is the first term here, the 25x squared. So that's kind of suggesting to us that a might be kind of 5x. Okay, then your b squared is usually the last one as well, so b squared is 4. So we can say here that b is going to be either plus or minus 2. Okay, so we're saying that b squared, b is some number, and when it's squared the answer is 4. That means that the number we started with must have been plus or minus 2. Okay, so b is some number, when we square it we get 4, So then b was plus or minus 2, the square root of 4, plus or minus the square root of 4. What that means for us is that our two answers are either 5x plus 2 or 5x minus 2. Okay, those are our two brackets for our perfect square. If we multiply that out, we can see we get 25x squared as we expected. We're going to get 20x, we're going to get 4, and over here we get the same again, 25x squared. This time we're going to get a minus 20, and we get our plus 4 again. So our two possible values for p are these two values here. So p is either equal to 20 or p is equal to minus 20. Okay, the key thing there, I suppose, is this bracket in the middle, these two brackets here. So remembering that a perfect square is an expression, a quadratic expression that can be written in this form of 5x plus 2 all squared, and when you multiply it out you get your quadratic. Identifying, I suppose, that if there's going to be two different values for this p in the middle, then it's going to come from that second number being maybe a different sign, so that we can still get that 4 at the end. And that's what we were doing at the start. When we got that b squared is equal to 4, then we had that idea that b has to be either plus or minus 2. And we did talk about this a little bit when we did our surds. So it's not necessarily that the square root of 4 is plus or minus 2, but it's that if we have some number b and that number squared is equal to 4, then the number we started with could be plus 2 or minus 2, and we just have to account for both those options. And then in doing that, that's how we come up with the two possible values of p. So that was the key thing there, I suppose, was the two possible values as well. Some people just were coming up with maybe one value, so it was finding just both of those values for that question.